Hello, grade 10 student, and welcome back. Today, we will cover lesson 5.3 Forces in Two Dimensions, part 6. We'll also work through the corresponding applications and homework questions. So let's get started. Now, mass, we mean by mass the amount of matter present in an object. It's a scalar quantity, which means it doesn't have direction. Now, the symbol that we can use as a notation for the mass or to describe the mass is the letter M, as well as the capital M. The property mass is a constant property within the object and doesn't change regardless of location. So, at any circumstances, whenever we deal with the same body with the same object, it means we have the same mass, regardless of the location that the object plays on it. So, for example, for a body that has a mass m on the Earth, it will have the same mass m but another planet such as Moon, Mars, etc. Now the SI unit of the mass is kilogram, kg. The other common units are gram, g, ton, t. Now the conversion factors for each of these two units into the SI unit is given by this relationship. So from gram to kilogram, we just divide by 1,000, and for the reverse direction from kilogram to gram, we multiply by 1,000. Now here, from ton to kilogram, we multiply by 1,000, and from kilogram to ton, we divide by 1,000. Application 1. Convert the following masses to SI units. Now here, as we can see, that the unit used to describe this mass is 300 grams, so the unit is gram. In order to convert gram to kilogram, we simply divide by 1,000. So 300 gram divided by 1,000 is equal 0.3 kilogram. For B, again, this unit is gram. So to convert this quantity into the SI unit, we just divide by 1,000. And 1,500 divided 1,000 is equal 1.5 kilogram. In part C, we need to combine the three masses together. However, in physics, we cannot add or subtract different units. This is ton, this is gram, this is kilogram. So we must unify the units into the SI unit. The given unit here is ton. So we must convert it into the SI unit. The SI unit is kilogram. This is why we must multiply it by 1,000. So the answer is, after converting, 1,500 plus. Now this unit is not the SI unit. The SI unit is kilogram, so we should convert it into the SI unit. The SI unit is kilogram, so we just divide by 1,000 in order to complete the conversion. And the answer is 5 kilogram. Finally, no need to do any operation here because it's already presented in kilogram. So we use it again. And we found the summation of the three masses, and the answer would be 1805 kilogram. Now, part 2, gravitational force or pull of the gravity or weight. So all of these three terms refer to the same meaning. It's a kind of field force or non-contact forces. We know that there's only three non-contact forces, and the gravitational force is one of them. The description, it's a measure of a gravitational force exerted on an object. So this type of force measure the gravitational pull that a planet exerts on an object. It's a vector quantity, which means we need to describe its magnitude and its direction. Now, the possible symbols for this force are the Fg for the force of gravity, the W for the weight, or the F gravity or force of gravity. All of these symbols are accepted, and we need only one of them to describe or to use it as a notation for this type of forces. Now, the direction always and forever, the direction of this force is perpendicularly downward. So it's acting downward no matter what is the configuration of the object or of the system. The effect, it acts on any object with mass. So whenever we have mass or a body, near or inside a gravitational field, then this force will be activated. Now, the other possible configurations for the system can be found here. What is common between all of these configuration is the force of gravity always pointed downward. So even on an inclined plane, or even if the object is placed on a table or pushed against a wall, always and forever the force of gravity should be drawing or pointed to the same direction. Now, to find the magnitude of the pull of gravity or the weight or the gravitational force, we can find it using this formula. The Fg is equal to m times g. Now, the Fg is the pull of gravity or the weight of the object, and it's expressed in Newton. The mass m is expressed in kilogram. The g represents the gravitational field strength. Another name can be used to describe this g as the acceleration due to gravity. And since it's acceleration, it has a unit of meter per second squared. And the other common unit for this g, since it's considered to be strength, gravitational field strength, then the second unit for this quantity is Newton per kilogram. So now we have two units to describe the same quantity, meter per second squared, Newton per kilogram, and they are equivalent. So in the question, whenever I saw this unit or that unit, it means directly it represents or it belongs to the G. Now the triangle can be constructed here to describe the relationship among the Fg, M, and G. From this triangle, we can obtain three relationships. The M is equal Fg over G, the Fg is equal M times G, and finally the G is equal Fg over M. Now, as the mass increases, the pull of gravity increases. This is known as directly proportional. So mass and pull of gravity are directly proportional. And when I say the mass increases, I mean by that we have changed the object itself in this context. Now, as the gravitational field strength increases, the pull of gravity increases. This is again directly proportional. And we can change the gravitational field strength by changing the planet itself, or when the object is placed at a very great altitude. Now, the weight of an object will change if object is brought farther away from Earth or placed on a different planet. So if we send Mr. KK to other planets such as Moon, and we wanted to measure its mass, it will remain the same because we have the same body on the other planet. However, what will change here is the G because we have changed the planet, so G will be changed, which means we will have new pull of gravity. If somehow we change the mass, which means we change the object, then we will experience new pull of gravity. So as the mass increases for different body, then the force of gravity will increase. If the G increases for different planet, then the Fg increases and vice versa, which means if we decrease the mass, the force of gravity will decrease. If we decrease the G, the force of gravity will decrease. Now, again, when we deal with the same object, then we will find that the mass won't be changed under any circumstances. Application 2. Calculate the weight in newtons of an object of mass 4 kg on the surface of Earth. Given the gravitational field strength near the Earth's surface is given by this value. So the G here is measured in Newton per kilogram instead of meter per second squared, and we know that the two units are equivalent here. Now we have information about the mass, we have information about the G, and they want us to find the weight, knowing that the weight is equivalent to the force of gravity. So these two terms, force of gravity, pull of gravity, the weight, all of these terms are referred to the same meaning, Fg. So we need to find the Fg now. So Fg is equal to m times g. The mass is given by 4, the g is given by 10, and the answer is 40 Newton. Now, application 3. On Mars, we have a new planet. The acceleration due to the gravity is 3.7 meter per second squared. Now we know that the g of Earth is equal to approximately is 10 Newton per kilogram or meter per second squared, as we saw in the previous example. Now this gravity is much less than the gravity on Earth, which means we will find that for the same object, we will have different force of gravity and it should be less. Now, what is the force of gravity acting on an object of 4 kilogram? Again, this is 4 kilogram, but this time on a different planet, and this planet is Mars. Again, we will use the same formula that we use in application 2, Fg is equal m times g. Now the mass is given by 4. Again, the g now it's different, 3.7. And the answer is 14.8 Newton. In the previous example, for the 4 kilogram, we found that the force of gravity on Earth to be equal 40 Newton. Now it's much less, and this is due to the what? Due to the change in the acceleration due to the gravity. Now it's less. This is why we got less force of gravity. Application 4, a mass m. So the mass here is unknown. Don't know what is the mass. Weights 120 Newton. From the unit, you can say this is force. And which type of force is this? This is the weight or the force of gravity on the surface of a planet. On this planet, the G is given by 20 Newton per kilogram, which is much higher than the one on the Earth. What will be the mass? Now, let's construct the triangle that is linked the force of gravity to mass and G. Since we are looking for the mass, let's hide the mass here. And the mass, it will be equal to the Fg over G. Now, the Fg is given by 120, the G is given by 20, and the mass is equal to 6 kilogram. Different materials rest on a table from greatest to least. Rank them by weight. And what do I mean by weight? By the Fg. Now, as we can see here in this picture, we have different materials with different sizes, but we know that the size has nothing to do with the force of gravity. We just focus on here on the masses. This is 2 kilogram, 10, 15 kilogram, 12 kilogram. Now we know that as the mass increases, the force of gravity will increase. We know that the highest mass is for B. We know, or we have, let's say, the highest mass is at B, then the mass of A, then the mass of C, and finally the lightest object is for D. Now then we can say as the mass increases, the force of gravity will increase. The force of gravity at B, because it's massive, then it will experience the highest force of gravity among these objects. Then the force of gravity acting on A, then the force of gravity acting on C, and finally the force of gravity that the object D experiences is the lowest. Application 6. The acceleration due to gravity on a planet is 12 meter per second squared, which is much higher than the force or the gravitational field on the Earth. We know that on Earth it's 10. Compared with her mass and weight on Earth, an astronaut on that planet has. So here in this choices, we need to choose one correct statement that describe correctly what will happen to the mass and the weight on that planet if we compare it with the ones on the Earth. Now let's start with the mass. Mass is the amount of matter is an object. It doesn't change with location. Whether the astronaut is on Earth or on any other planet, the mass stays the same. So the mass always and forever for the same object, no matter what is the place that the object uh, we put it on it, then the mass will stay the same. Now, let me write here, mass is the same because we have the same body in different planets. Now, what about the force of gravity? We know that the force of gravity will be affected under the G itself. If the G increases, the force of gravity will increase. And if the G decreases, the force of gravity will decrease. But here, If we compare it to Earth, according to the question, this planet has much higher G, which means the G increased. As a result, the Fg will increase again. Now, the force of gravity will increase here. Remember that the force of gravity is represent the weight of the body. So the weight of body will increase and the mass will stay the same. This is why I will choose D because it describes correctly this situation. The same mass won't be affected and more weight. Application 7, the force diagram shows the pull of gravity on an object. Given that the object is near the Earth's surface where g is equal to 10 meters per second squared, the mass of the object is, so here we need to find the mass. What do we have here? We have the g and the force diagram. We know that the force diagram is used to represent the arrow or the vector of the force. Now the vector of the force here represent the Fg. So from the length of this vector, we can know what is the magnitude because the length of the vector represent its magnitude. And this magnitude is the magnitude of the Fg. Now let's find first the force of gravity or the magnitude of the force of gravity. We know that the force of gravity is given by 1, 2, the number of grids multiplied by the scale. So it's 2 times 50, and the answer is 100 Newton. Now, since the force of gravity is related to the mass, we can use the force of gravity to find the mass, and the mass is given by Fg over g. Now the Fg is 100, and the g is given by 10, and the answer is 10 kilogram. This is why the correct answer here is B. Now the homework section, question 1. On Earth, Mr. KK has a mass of 100 kilogram and the weight of 1000 Newton. He is going to be the first person to set foot on Mars, which has a gravitational field strength 3.7 Newton per kilogram. How will Mr. KK's mass and weight change on the Mars? So among these sentences or choices, we need to choose one correct statement that describe correctly what will happen to the mass and the weight of Mr. KK on that planet on Mars. Now, since we have the same object, but now in different planets, same object means same mass. Now we know that the mass won't be affected under the changes in location. This is why we have the same mass. Now, what about the weight? The weight represents the force of gravity, and we know that the force of gravity will be affected under the change in the G. Now, if the G increases, the force of gravity will increase, and if the G decreases, the force of gravity will decrease. Now, 3.7 Newton per kilogram is less than the gravitational field strength on the Earth, which means the G decreases. This is why the force of gravity will decrease. So we have less weight or force of gravity and same mass. This is why the correct answer here should be A. An object with mass of 31 kilogram has a weight of 465 Newton on a planet X. The acceleration due to the gravity on that planet is given by G is equal force of gravity or the weight over mass. Now the force of gravity is 465 Newton, the mass is 31, and the answer is 15 meters per second squared. Now another way to solve the same question from the given unit, we can figure out the correct answer because the only correct unit that used to describe the acceleration due to the gravity is found in B, because meter per second, kilogram per Newton, and Newton are not the correct units for the acceleration due to gravity. Only B has the correct unit, which is meter per second squared. Question 3, three masses E, F, and G, where the mass of E is given by 2 kilogram, the mass of F 400 gram, the mass of G is 0.5 kilogram. The total weight, the total force of gravity of the masses is given by. Now to find the total weight, we need first to find the total mass, and the total mass is given by the mass of E plus the mass of F plus the mass of G. Now we must have consistency in the units. The only odd unit here is the G. We need to change it to the SI unit. We must convert it into the SI unit. Now the mass of E is 2 kilogram. The mass of F is 400 gram. Now in order to convert G into kilogram, we divide by 1000. Now the mass of G is already given in kilogram and no need to do any changes here. And the mass will be, the total mass is 2.9 kilogram. Now we will use this total mass to find the total force of gravity or the total weight. Mass times G. Now the mass is 2.9. The G is given by 10. And the answer 29 Newton. This is the H. That's it for today. Thank you for watching and see you in a new video soon.